Hi everyone! Today we'll be talking about isosceles and equilateral triangles. Please remember to write down the FLT. Given an isosceles or an equilateral triangle, I will be able to use its properties to find missing side lengths and angle measures. So let's take a look at isosceles triangles first. An isosceles triangle is a triangle with at least two congruent sides. So here's a triangle, and I know that it's an isosceles triangle if it's marked like this, showing that the two sides are congruent. The two congruent sides are called the legs of the triangle. The angle formed by the legs is called the vertex angle. The base is the side opposite of the vertex angle, and the base angles are the angles that have the base as a side. I know I kind of just threw a bunch of words at you just now, but you can think of the base as just the side that's not congruent, and the base angles are the angles right by the base. And there's this theorem called the base angles theorem, and it states that the base angles of an isosceles triangle are congruent. So the base angles of an isosceles triangle share the same angle measure. So for example, here is an isosceles triangle, and notice how the two base angles are marked as congruent. And regardless of which way the isosceles triangle is facing, it's always the base angles that are congruent to each other. Also note that the converse of this theorem is true, so not converse like the shoes, but the statement in reverse. So if two angles of a triangle are congruent, then the triangle is an isosceles triangle. So if you see two angles that are congruent to each other, that means your triangle is an isosceles triangle. So let's use this theorem to take a look at some examples. Our first example asks us to find the measure of angle A. Notice that I have an isosceles triangle because the sides AB and AC are congruent to each other. That means angles B and C, the base angles, are congruent to each other. So angles B and C have the same angle measure. So let me write this out. Angle B is congruent to angle C, which means the measure of angle B is equal to the measure of angle C. So this angle right here also measures 46 degrees. We also know that the interior angles of a triangle add up to 180 degrees. So the measure of the three angles will equal 180 degrees. And we don't know what the measure of angle A is, that's what we're trying to find. But we do know that the two other angles are 46 degrees each. And from here, let's solve for the missing measure of angle A. So we can combine 46 degrees plus 46 degrees. And so that is going to be 92 degrees equals 180 degrees. And to isolate the measure of angle A, we're going to subtract 92 degrees from both sides. And we're left with the measure of angle A equaling 180 degrees minus 92 degrees, which is 88 degrees. So we were able to find the measure of angle A using the fact that we have an isosceles triangle. And in an isosceles triangle, we know that base angles are congruent. Up next, we have a similar example just with a few more steps. We are going to find the measure of angle T. Once again, I have an isosceles triangle where the sides TR and TS are congruent to each other. By the base angles theorem, we know that the base angles R and S are congruent to each other. So angle R is congruent to angle S, which means the measure of angle R equals the measure of angle S. We know that the measure of angle R is x degrees, so the measure of angle S is also x degrees. Now let's set up an equation to first solve for x. So the measure of angle R plus the measure of angle S plus the measure of angle T equals 180 degrees. And let's fill in the information that we know. We have x degrees plus 3x degrees, that's the measure of angle T, equals 180 degrees. We can combine like terms. X plus 3x is 5x. So 5x degrees equals 180 degrees. And divide both sides by 5. And we've solved for x. X equals 36. But we're not exactly done yet, because for this example, we have to find the measure of angle T. So we just found out that x equals 36. Now let's plug this into the measure of angle T. So the measure of angle T equals 3x degrees. Let's replace x with 36. So the measure of angle T equals 3 times 36 degrees. And then what's 3 times 36? That's 108. So the measure of angle T equals 108 degrees. So here we use the idea that base angles of an isosceles triangle are congruent to each other. Then we solved for x and then found the measure of angle T. Let's look at one more example for isosceles triangles. Here we have the triangle PQR, and we are asked to find the measure of angle P. This triangle is an isosceles triangle. Which sides are congruent to each other? Sides RP and RQ. And then which ones are the base angles? The base angles here are angle Q and angle P. So we know that these two angles are congruent. So that means the measure of angle P equals the measure of angle Q. And we're given this measure of angle Q. So we know that the measure of angle P equals 3x plus 3 degrees. So let me write that over here. Angle P measures 3x plus 3 degrees. So now we can set up an equation to solve for x. We know that the three angles will sum to 180 degrees. And we're given each of these angle measures. So 3x plus 3 degrees, that's the measure of angle P, plus 3x plus 3 degrees, the measure of angle Q, plus 5x minus 2 degrees, that's the measure of angle R, equals 180 degrees. And let's simplify this by combining like terms. So we can combine 3x plus 3x plus 5x. What does that sum to? It sums to 11x. And then next we can do 3 plus 3 minus 2. And that equals 4. So we have 11x plus 4 degrees equals 180 degrees. We're going to subtract 4 degrees on both sides. And we have that 11x degrees equals 176 degrees. And then what do we do next? We divide both sides by 11 degrees, and we get x equals 16. So we've solved for x. Now let's find the measure of angle P. So we just found that x equals 16. And the measure of angle P is going to be 3x plus 3 degrees. Let's replace x with 16. So we have 3 times 16 plus 3 degrees. 3 times 16 is 48. And 48 plus 3 equals 51. So the measure of angle P equals 51 degrees. All right, so we looked at isosceles triangles. Now let's look at equilateral triangles. An equilateral triangle is a triangle with 3 congruent sides. So we know that this triangle is an equilateral triangle because the 3 sides are marked as congruent. And we also have equiangular triangles. An equiangular triangle is a triangle with 3 congruent angles. So a triangle like this, where the 3 angles are marked as congruent. And we actually have a theorem about equilateral triangles. If a triangle is equilateral, then it is equiangular. So that means if you have a triangle with 3 congruent sides, then the 3 angles are congruent as well. And the converse statement, the reverse statement, is true as well. If a triangle is equiangular, then it is equilateral. So if you have a triangle with 3 congruent angles, then you know that the sides must be congruent as well. Now let's use this theorem to solve some examples. So here's our first example for this part. We are going to find the length of the side EF. Notice here we have an equiangular triangle because the 3 angles are marked as congruent. That means the triangle is equilateral as well, so the 3 sides are congruent, which means that side DF is congruent to side EF. The 2 sides have the same lengths, so we can set up an equation to first solve for x. So we have 5x minus 12 equals 3x minus 4. I'm going to add 12 on both sides to move the constants over to the right side. So we have 5x equals 3x, and then negative 4 plus 12 equals positive 8, so plus 8. Next, I'm going to move this 3x over to the left side by subtracting 3x from both sides. So I have 2x equals 8. I divide both sides by 2, and I get x equals 4. But we're not exactly done yet. We have to find the length of the side EF. So we just found out that x equals 4, and we know that the side EF has a length of 3x minus 4. Let's replace x with 4. So we have 3 times 4 minus 4. That's going to be 12 minus 4, which is 8. So the side EF measures 8. The length of side EF is 8. So for this example, we were given that the 3 angles are congruent to each other. And that means that the triangle is also equilateral. So we were able to set the side lengths equal to each other to find the length of side EF. For example 2, we are asked to find the value of x. So in this problem, we're simply solving for x. notice that we have an equiangular triangle because the three angles are marked as congruent. That means the triangle is also equilateral. So I know that the side MN is congruent to the side LN. That means I can set the two side lengths equal to each other. So x plus 15 equals 7. To solve for x, I subtract 15 on both sides. This cancels out, and I'm left with x equals -8. And since we're just asked to find the value of x, this is it. We're done with this example. Let's look at one last example for this lesson. Once again, here we are asked to find the value of x. Notice here we have an equilateral triangle because the three sides are marked as congruent. What does this mean? We know that the three angles must also be congruent to each other. They're equiangular. So I know that angle J is congruent to angle L. So the measure of angle J equals the measure of angle L. So I can set up an equation based off of this. Since the two angle measures are equal to each other, we have 60 degrees equaling 6x minus 12 degrees. I like to have x on the left side, so like any variables I like on the left side, so I'm just going to flip this around. 6x minus 12 degrees equals 60 degrees. Let's add 12 degrees on both sides. So we have 6x degrees equal 72 degrees. Divide both sides by 6, and we are left with x equals 12. We were able to find the value of x by using the fact that the angles are congruent to each other. Here's a quick review for today's lesson. An isosceles triangle is a triangle with at least two congruent sides. The base angles of an isosceles triangle are congruent to each other. And an equilateral triangle is a triangle with three congruent sides. And an equilateral triangle is also equiangular, meaning that the three angles are congruent to each other. Awesome job today, and please remember to submit your notes on Canvas.